Is you have to pick up 3 of these all semester. The good news is at least you can leave one at home now, and you got a whole new one. You don't have to bring a big thick one. You bring the 3rd that you need, right?
Like the same thing.
What's that?
I think there's ones actually.
What's that?
Oh, you're saying all.
Did you get the wrong one?
No, I have it. I was just saying. I think this one's like a tiny bit thinner.
Say it louder.
I think this one's like a tiny bit thinner.
Yeah, I think you're right. And maybe the last one will be even thinner than this. You know, we're on the diet plan. We hope. Okay. Are you recording? What? Okay, you're good. All right, that's all right. We're not going to worry about efficiency today. We're going to cover all this stuff in chapter 2. Let's go to this right here. One process to rule them all. What movie is this from?
Lord of the Rings.
Lord of the Rings, yeah. One ring to rule them all. If you don't know the Lord of the Rings, you're missing out. Okay, I want you to do something right now, and I actually want you to write this process in this open space here. So you're going to recreate this whole thing right here, okay? Go ahead and do it. There's a little asterisk up there that says we must memorize this, and to memorize it, we're going to need to write it a few times. So we're going to write this a few times over this next 2 weeks, this week and next week. I'm going to go over to the far left board, and I'm going to set the example, and I'm also going to write it, okay? And you can pause for a second, Grace. That process to solving, okay? So I told you about Papa Paul Murphy from back east who came and flew here to look at my book, and this is actually the process that really got him here. He loved this, and this is awesome. That's why it's one process to rule them all. Everything we do in chapter 2 is a solve problem. We said everything in chapter 1 is a simplify, everything in chapter 2 is a solve problem. And this process is everything you need to know. It will allow you to do every single problem, every single section. So we learn this process, we learn how to do everything in this chapter. That's powerful. So we're going to write this down. We've got to memorize it. Our goal when we're solving is to get the variable alone. So right now, on top of x, I want you to write the variable. The variable. Okay? Why do we say x? Because it's a little more shorthand than saying the variable. And x is the most common variable in algebra. Okay? And so down here it says get all your x's to one side. It's get the variables to one side. Right? You can add the variables there. Okay? It's very ironic that if there's 2 types of problems in all of algebra, solve and simplify, your first step is to simplify the equation. And we're going to clean it up. We're going to get rid of fractions. How do we get rid of fractions? We do that by multiplying all the terms by the LCD. And you know what a term is. And you know what an LCD is because we did all of our Karate Kid basics. You know how to distribute parentheses. We just learned that. We got combining like terms and getting all our x's to one side. But we aren't going to do any of this step today. That's Wednesday. Today we are focusing on the addition and multiplication principles. All right? And that's what we're going to do in this 3-step process to solving today. And then we'll jump into this. So we're working backwards, so to speak. Let's go ahead and go to our next page here. The balance rule. So if math is the manipulation of numbers to look different but remain the same, then the number 1 tool of manipulation in the solve realm is what we call the balance rule. And I know you guys are familiar with this. So let's go ahead and finish this statement. Whatever I do to one side of an equation, I must what? Okay, so I want you to end this with, whatever I do to one side of an equation, I must do the exact same to the other side. So write that. Do the exact same to the other side. I must do the exact same to the other side. So let's say, as we have up here, let's say I have a scale, as you have in your book. And I got a 5-pound weight on this side. And if you think about this, this is balanced or equal, right? So if I throw a little 2-pounder right here, what's going to happen? You guys tell me, what's going to happen? It's going to drop to the left, okay? But if I hurry and I throw a little 2-pounder here, what's going to happen? It's going to balance out. So this is the law of physics and the law of math. Whatever you do to one side of a balanced equation, an equal sign, you must do the exact same thing to the other, or you will lose your equality. You'll lose your balance. So if I, where is my erasers? If I subtract, this 2-pound weight, get rid of it. What happens to this scale? What happens? Drops to the, but if I hurry and I subtract this one, what happens? Yeah, it balances out again. So whatever you do, you got to do the exact same thing to both sides. So what is 23 equals 23? What is that all about? If I multiply this side by 2, I get 23 equals 46. True statement or not? Of course it's not true. So we got to say, well, if I multiply this by 2, do the same thing on both sides, I get 46 equals 46. Right? If I subtract 4 here, I get 42 equals 46. Not a true statement, so we got to say, all right, well, let's subtract 4 here. Do the same thing on both sides, I get 42 equals 42. If I divide this by 6, I get 7. I got to divide that by 6, I get 7. And on and on and on. So whatever you do to one side of the equal sign, you got to do the exact same thing to the other. So under 23 equals 23, I would write this down. Don't worry about the scale. The scale is just an example, and we're good to go, okay? You guys write all that down? Okay. As you're writing, I'm going to drop to the next section here. As we learn the 3-step process to solving throughout the semester, or throughout the next couple of weeks, we can shorthand it, okay? And this is a good example of how to shorthand it. There it is in all of its glory, 3-step process to solving. The goal is to get the variable alone. We're going to talk here in just a few minutes. What does that mean to get x alone? We're going to simplify the equation. And so right here, these are just prompts to help you remember. Fractions, parentheses, like terms, one side. But if you don't know what you're doing with fractions, you got to memorize that. The full process over there. Get rid of fractions. How? Multiply every term by the LCD. Parentheses, what do we do with parentheses? We distribute them. What do we do with like terms? We combine them. Okay, and we got to get all of our variables to one side. And then we will do the addition and multiplication principle. So in this section, these sections 1, 2, and 3a, we're going to do just the addition and multiplication principles today. I want to talk about this right here. Okay, we're going to, when we're doing the addition and multiplication principles, we need to understand in the addition and multiplication principles, there's kind of 2 questions and 1 command. Okay, who's sharing sides with x? Okay, your variable. Again, you can say the variable. We're just going to say x to make it quick. What are they doing to x? What are they doing to x? Now again, all this is written for you. I'm just writing this right now. It's all right there. I'm just writing this on the board so we can reference it. And we're going to get off this page here. And we're going to do the opposite to both sides. Now when we say what are they doing to x, and we're going to do the opposite to both sides, what are we talking about? Sorry, that's an exclamation mark, not a question mark. We're talking about add, subtract, multiply, and divide. The operations. Okay? How many of you have a little sister? How many of you have a little sister? Okay? You can pause this for a second. Cameras. I have the little sister analogy on YouTube already, but just in case somebody's really nervous or something. Okay, x plus 7 equals 10. Before we do this, I want you to look up here. The addition principle, there's a little arrow that says or. This is the addition or subtraction principle. So write subtraction on that line. It is not called the addition or subtraction principle, but both addition and subtraction apply here. There's not a separate principle called the subtraction principle. The addition principle covers both addition and subtraction. Let's go down to this one here. The multiplication principle. What do you think that's going to be? Multiplication or what? Division. That's right. Okay, it's not called the multiplication or division principle, but both multiplication and division are taken care of, and there is not a separate principle called the division principle. It's taken care of in the multiplication principle. Okay? All right, let's come over to this board. X plus 7 equals 10. Who is sharing sides with x? 7. What's it doing to your x? Addition. What's the opposite of addition? And you're going to do that to both sides. Why? Because of the balance rule. What you do to one side, you got to do to the other side. 7 minus 7 is gone. Makes x plus 0, which is just x. X is alone. 10 minus 7 is 3. Very good. And we could do this problem in our head. But there are other problems sometimes that pose a little more difficulty that we can't do in our head. Maybe x minus 2 equals negative 12. Okay? And you're like, Brother Rich, I'm so smart I can do that in my head. Good. I hope so. But for the rest of us that aren't as smart, myself included, we will like to use some algebra here. Okay? Who's sharing sides with x? 2 or negative 2. What's it doing to x? Subtraction. What's the opposite of subtraction? Addition. And so we're going to add 2, right? And what we do to one side, we got to do to the other, so we're going to do this to both sides. Negative 2 and positive 2 do what? They cancel each other out. X is alone. Negative 12 plus 2. What is that? That is negative 10, right? Different signs, they're being added, right? Different means difference. Different means subtract. 12 minus 2 is 10. Larger number is negative. X equals negative 10. Now the beauty of solved problems is you can check your answers. And so tonight, in your homework, you're going to be required to check your answers. And I want to go through this with you, okay? We didn't do it on the first one. We're not going to do it on every problem today that we use as examples, but you need to do it on all your homework tonight. You need to go back and check your answers. If you do that, I will never require you to do it again for the rest of the semester. But tonight, you need to do it. And the reason you need to do it is because you need to become fluent in how to check your answers. And you need to see what kind of problems come up sometimes when you check your answers, so that if you're taking a test, you're prepared. You get what I'm saying? It's kind of like this game I was talking about that my girls won this weekend, okay? One of the things that was critical is the first thing I did before practice this week is I invited them all over for dinner. And while they ate dinner, I have this huge big screen TV on the wall, and I pulled up video footage of their last game that they lost. And I made them watch themselves. And it's fascinating. Has anybody ever watched themselves to try to get better in their sports or anything that they do? You got a video of yourself, you watch yourself, yeah? What did you watch, Faye?
Ballroom dancing.
Very cool. Very, very good way to get better. You definitely can see your footwork and your moves and all that kind of stuff. Very good. What'd you do?
I did that with wrestling.
Very cool. Yeah. Yeah.
Baseball.
Baseball. Yeah, absolutely. Your swing and all this stuff. It doesn't matter what you do. If you're doing something physical out there, if you video yourself, you can learn so much. And the girls were stunned because they weren't playing defense like this. They were playing defense like this. This is what I call resting butt syndrome. Okay? It's like you're just kind of resting your butt right here, okay? And I told them, look, that you can't win a game in that position. You're getting beat by your girl to the basket over and over again, right? Just stuff like that. And so, why did I bring that up right now? I have no fetching idea, but it's on YouTube, so it makes it more worthwhile. All right. No. Checking your answers. Here's what's up. You can tell somebody you need to get in defensive stance, and they won't do it. But they'll say, yeah, I do. And they get on the court and they don't do it. But then they see themselves and are like, oh, I don't look so hot. And then they start to do it, right? Same kind of a thing here, checking your answers. I can tell you to check your answers, and if you don't do it, then when it matters, it won't be there for you, right? Same kind of a concept. If we don't get into the habit of getting in defensive stance in practice, so before we went to practice, we watched, they could see themselves. So my point is, you need to spend some time checking answers so you understand what the strength and the weakness is. We'll talk about our strengths and weaknesses of checking answers in our class next time. So let's check this. The first thing we do, we write the original problem. X minus 2 equals negative 12. So you're going to write the original problem. Okay? This all night tonight in your homework or whatever you do it. This afternoon, tomorrow, whatever. 6 o'clock in the morning on Wednesday. Okay? I doubt. Who's up at 6 a.m.? Raise your hand. Ooh, a couple of early risers in here. Impressive. Okay?
It's 5:30.
All right. X equals negative 10. So where there's an X, I put in a negative 10. I substitute that in. So this next step is to sub it in. Sub it in. Sub in the answer. 10 minus 2 equals negative 12. Do you agree with me? This is negative 10 plus negative 2. All subtraction converts to addition, yes? Yeah. Or you can plug that in your calculator. Absolutely. You can do that. Okay? You have a calculator. You can use it. And so these have the same sign. Same means sum means add. This is negative 12 equals negative 12. That is a true statement. I know this math is true. This math is true. Do you know that song?
The one that's like, ha.
Yeah.
Ha, ha.
Oh no, you're thinking of take on me. take on me. No, okay, we won't do that. Yes, I know. It's Just Dance. Just Dance. Okay, here's the deal. How come we didn't get the answer? See, I get students sometimes like, well, if you plug it in, why didn't you get the answer again? That's not what we're doing. We're testing our answer to see if we get a true or a false statement. Let's say that we said negative 12 plus 2 equaled positive 10. Accidentally, we forgot the negative. And we said x equaled 10. Let's just say that we did that, okay? So we come back, we take our original problem, x minus 2 equals negative 12. And then where there is an x, we put in this answer, so we have 10. And then we have 10 minus 2 equals negative 12. What does 10 minus 2 equal? What does it equal? 8. Does 8 equal negative 12? False. Okay, so that answer is not correct. Incorrect. Okay, or this answer is correct because we got a true statement. Does that make sense? Check your answer, you're going to get a true or a false statement. If it's true, then your answer was true. If it's false, then your answer is incorrect. Unless what? You did your check incorrectly. That's the weakness of checking your work. So tonight when the problems are easier, I want you to do that. You guys cool? Hard or easy?
Easy.
So notice, we cover it looks like we cover 3 sections in here because it says this is 2.1, 2.2, and 2.3a. 2.3a though is like about 16% of an assignment. So this is like 2.2 assignments tonight, right? So we just finished the first one, the addition principle. Let's talk about the multiplication principle. What are we for? 3x equals 15. Who is sharing sides with x? 3 is. What's it doing? Multiplying. And what's the opposite of multiplication? Division. And so you're going to divide, well, let's go ahead and write 3x over 3 equals 15 over 3. These cancel. 3 divided by 3 is 1. 1 times x is just x is now alone. 15 divided by 3 is 5. Well, you knew this. You could do this in your head. But if we get to things that we aren't as comfortable doing in our heads, like x over negative 2 equals positive 12, okay? Who's sharing sides with x? Who?
Negative.
Everybody.
Negative.
And what's it doing?
Dividing.
Dividing. What's the opposite of division? Multiplication. So you're going to multiply negative 2 times x over negative 2 equals negative 2 times 12. Cross cancel. Those are gonzo. X equals negative 2 times 12 is negative 24. Okay, got to check our answer. So we're going to say, let's check that. Write the original problem, x over negative 2 equals 12. Where there's an x, we will put in our answer of negative 24. We get negative 24 over negative 2 equals 12. What's a negative over negative? Positive. 24 divided by 2? 12 equals 12. Check, that is true. And so our answer is correct. Hard or easy?
Easy.
Easy. We cool? Okay, we've taught you everything in sections 2.1 and 2.2. Do you feel comfortable? Who's sharing sides with x? What are they doing to x? Do the opposite to both sides. Okay? This is your quiz today. All right? So let's look up here. Going to give you guys some time to do this. Grace, you can go ahead and pause. 8. What's it doing?
Addition.
It's being added to. So we're going to subtract 8 from each side. 12 minus 8 is y equals 4. Who got y equals 4? Say woo. Woo. Okay, all right. We're done with that one. X minus 7 equals negative 21. X minus 7 equals negative 21. Who's sharing sides with x? What's it doing? We're going to add 7, add 7. X equals, negative 14. Agreed? Yeah. Okay, again, you can use your calculator here, but 21 minus 7 is 14, different sign, all that kind of stuff. Okay? We're not going to get into all that. Y plus 1/3. Y plus 1/3 equals negative 1/7. Who's sharing sides with y?
1/3.
1/3. What's it doing?
Adding.
It's being added, so we're going to subtract. Okay? All right, so this cancels. We get y equals negative 1/7 minus 1/3, which is also known as plus negative 1/3, right? Listen, guys, you got to be able to put that in a calculator. That's why I love that you're talking about the A, B over C button. But, if you got to do this on your own, you multiply this by 3 over 3, because why? Because the LCD is 21. So you get negative 3 over 21 minus 7 over 21, or plus a negative 7 over 21, which makes negative 10 over 21. Say woo if you got that right.
Woo.
Good. Okay. Let's do these together. Let's do these together, okay? Let's rip through these. 12 equals what? A minus 8.2. Does it matter what side the variable's on? No. The goal is to get the variable alone. It doesn't matter if it's on the left side or the right side. Who's sharing sides with A? 8.2. It's being, so we're going to add. So we're going to add 8.2. We're going to add 8.2. And we end up with 20.2 equals A. Say, well, if you got it right. Good. All right, so that covers the first four. Notice, we go back to this. The goal is to get the variable alone, right? The variable can be A, Y, B, C, X, whatever. All right, what's our next one? Negative X equals negative 1. I like this one. Kind of cracks me up a little bit, okay? Negative X equals negative 1. Who's sharing sides with X?
Negative 1.
Yeah, the negative. And it is, in essence, as you state very profoundly, it is a negative 1, right? And what's it doing to X? It's being multiplied, so you gotta divide. And what you do to one side, you gotta do the other. A negative over negative makes a, so now X is alone. A negative over negative makes a positive 1. If you go to check this answer, negative X equals negative 1, right? You plug a 1 in there, negative 1 equals negative 1. Ding, 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 it's a winner, right? We're not checking these, okay? If you're checking them, that's cool. But I told you on your homework you gotta check them, but right now I just want you to rip through these and see if you can get them. Y over 3 equals negative 9. Y over 3 equals negative 9. Who's sharing sides with Y? Yeah? Y over 3 equals negative 9. What's it doing? It's dividing. So you're going to multiply. So you're going to multiply this side by 3 and this side by 3. What you do to one side, you got to do the other. These cancel. Y equals negative 27. Say, Wolf, you got it right. Okay? All right, negative 13x equals negative 78. Negative 13x equals negative 78. Who's sharing sides with X? Yeah, not just the 13, but the negative, right? We got to get rid of the negative, the whole 9 yards. So we divide this by negative 13 because we were multiplying. Opposite of multiplication is division. These cancel. X equals, what's a negative over negative? Positive. Divided on a calculator, you got 6, didn't you? Say, Wolf, you got it right. Okay, cool. All right, so these fraction ones are giving you fits. They don't need to. Negative X over 8 equals what? What is it?
Negative 56.
Negative 56, thank you. Okay, who is sharing sides with X?
8.
8 and
Negative.
the negative. We don't want to know what negative X equals. X has to be alone, all alone. No negatives, nothing. It just has to be X, isolated by itself.
Negative 8.
Okay, so we're going to multiply this by negative 8 and multiply this by negative 8. Agreed? Now notice, what's a negative times a negative? It's a positive. Those cancel. And 8 over 8 cross cancels. X is now alone. Negative and a negative make a positive. 8 times 56 is?
448.
448. Say, Wolf, you got that right. Good. Last one. Negative 3/8x. Negative 3/8x equals what? Negative 15/16 or just 15/16?
Negative 15.
Positive or negative?
Negative.
Negative. Okay. All right. Who's sharing sides with X?
Negative 3/8.
Negative 3/8. What's it doing? It's multiplying. What's the opposite of multiplication? Drop your pens and pencils and look up here. So you're going to take, if you look at this, you're going to take negative 3/8 and you're going to divide that by negative 3/8. And over here you're going to divide this by negative 3/8. Yeah?
Yeah.
Because you're going to divide, because you're multiplying. Anything divided by itself equals what? Anything divided by itself equals what? What's 7 divided by 7?
1.
What's 10 divided by 10?
1.
Okay, so what's negative 3/8 divided by negative 3/8? And if you do the math, negative 3/8, change division to multiplication, flip the second fraction, what happens? Cross cancel. It's all gone. You're just left with X equals, right? Okay, this is negative 15 over 16. It's pen. Crap. Missed. I told you I'd coach it. I can't play it, right? Those who can do, those who can't teach. There we go. And change division to multiplication, flip the second fraction. Isn't that a better looking pen? It's so nice. Okay? A negative and a negative cancel each other out, right? 3 goes into this 5 times. 8 goes into this 2 times. You ended up with 5 over 2 here. Say, Wolf, you got it right. Good. Okay? Let's go back to the top of this. Let's go back to the top of this. Is 12 a solution to x plus 17 equals 29? What's 12 plus 17? 29. So the answer is? Yes. Is 5 a solution to 2x equals negative 10? What's 2 times 5?
10.
Does 10 equal negative 10?
No.
No, so it's not a solution. We clear? Okay, super easy. Let's go to our last section. We're going to wrap this up for the day. All right, section 2.38. So, Karate Kid. Remember Karate Kid, right? So, he learns one move at a time. Hanging up the coat is just blocking one shot, right? Painting the fence, that's just blocking one shot, right? So Mr. Miyagi throws a single punch at him and he can block it, okay? But fights don't work that way. There's a sequence of punches going on. And so you got to put all the moves together, right? So we just learned one move, the addition principle. Then we learned another move, the multiplication principle. But the reality is the three-step process to solving is putting them all together so we can fight and do all the moves in sequence, okay? One after the other after the other. But there is a sequence by which we need to do it. And we need to follow the order of the three-step process as it reads. The first one is the addition principle, and the second one is the multiplication principle. Why can't we reverse that order? Why can't we do the multiplication principle first and then the addition principle? Well, the answer I'm going to tell you and then I'm going to show you. The answer is because it creates fractions. Write that down. Because it creates fractions. Okay? All right, so if the first step in the three-step process to solving is to get rid of fractions, why the fetch would we want to create them, right? We don't want to create fractions. We hate fractions. They're hard. They make things more difficult. Yes?
And you're trying to like unwrap, like my math teacher in high school talked about like unwrapping the box. So like addition is like the outer layer, and then you're just trying to get x by itself.
Yes, I like that analogy. I like the analogy of unwrapping it to ultimately get to the gift or to X all by itself, nothing wrapped around it. I like that. Very similar concept to getting it alone, okay? Unwrapping it. I like that. Okay, so check it out. Our first problem here, 2x plus 5 equals 7. Let's look at this. 2x plus 5 equals 7. All eyes up here. Who is sharing sides with x? Drop your pens and pencils. Listen, this crap here, it's so easy. I know you can do this. And you're like, I can do this. I know you're smart. But I want to show you some things that'll make a difference tonight. So look up here. 2x plus 5 equals 7. Who's sharing sides with x? 2 and 5. Okay? But we want to do it the addition principle first. So we're going to ask who's being added or subtracted to our x? Who? 5 is. And what is it doing? Being added. So we're going to subtract. So that's our first move. So in this here, we're using these processes together. You know, we're not just making one move, right? We can block the kick and the punch, but I just did it opposite. So anyways, obviously I'm not teaching karate today. I'm teaching algebra, okay? So this is gone, and we get 2x equals 7. Now who's sharing sides? Well, wait a minute. Is that what we do? No, because we got to do this to both sides, right? Don't make that mistake. And that is actually the number one mistake that students make on their homework. Is they get kind of caught up in this. You got to do it to both sides, balance rule. And we get 2x equals 2. They make life a lot better. Okay? Now who's sharing sides with x? 2. And it's being, so you're going to divide. So you divide by 2, divide by 2, and x equals 1. Now tonight, you got to check all your answers, and you're being asked to check this answer. And so we're going to take the original problem, 2x plus 5 equals 7, and then we're going to take this other guy right here, x equals 1, where there's an x, we'll put in a 1. And we're going to have 2 times 1 plus 5 equals 7. What's 2 times 1? 2 plus 5? 7 equals 7. Check. It is true. And so that answer is correct. We good? Hard or easy? Watch this though. What if 2x plus 5 equals 7? What if you decided to divide by 2 first? Well, guess what? You have to divide that by 2. Because whenever you do this, you got to do it to all the terms. And you got to divide that by 2. And so this will cancel. You get x plus 5 over 2 equals 7 over 2. See how we created fractions? By doing the multiplication principle first? That's why we have to do it in order. We don't like fractions. We don't want to deal with them, so don't do it. Do the addition principle first. We cool? Okay, so no Fumar. Don't smoke that dope. We cool? Okay? Now. Okay? Go ahead and pause for just a second. Minus 19 equals 5. 4x minus 19 equals 5. You're like, Rich, what meds are you on? I'll share if you share. I'm just kidding. Look up here. Who's sharing sides with X?
4 and 19.
4 and 19. So we want to get rid of which one first?
19.
19 because of the addition principle. So what are we going to do? Add 19. What we do to one side, we got to do to the other. This cancels. We get 4x equals 24. Now what do?
Divide.
4 sharing sides. It's being multiplied. So we're going to divide by 4, divide by 4, and x equals 6. We go to check this answer. We got 4x minus 19 equals 5. Where there is an x, we will put in a 6. And we get 4 times 6 minus 19 equals 5. 4 times 6 is 24. 24 minus 19 does equal 5. 5 equals 5. Check, that is true. The answer is correct. Last and final one. Negative 91, we're going to do this right here. Negative 91 equals, help me, 9y plus 8. Yes?
Yes.
Okay. Does it matter that y is over here? Nope. Just want to get it alone. Or unwrap it, as your old teacher used to tell you. Okay? Who's being added or subtracted to y? 8. So what are we going to do? Subtract. It's being added, so we're going to subtract. And negative 91 minus 8 makes negative 99. Because we get to add them because they have the same sign. Who's sharing sides with y now? It's being multiplied, so you're going to divide this side by 9, divide this by 9, you get negative 11 equals y. I'll let you check it on your own time, your own dime. You guys are awesome. Homework will be easy tonight. It'll go fast. Okay, you guys have a great one. When's the last day to take the Chapter 1 test?
Tuesday.
Tomorrow. Get it done. See you then.